All right, so let's do this 5-minute check real quick. Evaluate the expression. Okay, let's plug that in and see what you get. Okay, so I kind of jumped ahead of you, but I did that first one, and you can see that the answer is 5, and then I plugged in the second one. I don't think that we really need to do that one together. And then the next one, remember, this is not parentheses, so you are not distributing. So 1.5 times 4 is 6 plus 2. So now I have 5, absolute value of 8. Absolute value of 8 is still 8, so 5 times 8 is 40. Okay, so solving equations. Do you remember how to solve equations? All right, so remember, a way to remember is that I have 2 bars here, right, for absolute value. That helps me remember that I have 2 equations. So the first equation is set to what it has right there. The second equation is set to its opposite. And now I solve. So the reason we do that is because we have a negative and a positive answer. So you have to use both of those. So that's why we have the positive here and the negative here. So now I subtract 20. I get b equals 1. I subtract 20. And I get b equals a negative 41. So now I have to check that. So if I check that, I plug in 1, I get 21. Yep, equals. I plug in negative 21 or 41, I get negative 21. Absolute value of negative 21, yes, is 21. So these both work. So the thing that you always have to remember with absolute value to check your answers, to be quite honest.
Ulysses, please come to the front office. Ulysses, please come to the front office.
Sorry about that. I'll call. So remember, you have to check your answers. You want to make sure they work. To be quite honest, this lesson is actually not this lesson, but the following lesson. And so I'm kind of giving you a little reminder on how to do these because you have seen these before. Then solving the equation. I have to have the absolute value by itself. So in order to do that, remember these are next to each other, so that's multiply. So I'm dividing both sides by 4. So I get the absolute value of a plus 5 equals 2. So now my 2 equations, a plus 5 equals 2. And I have a plus 5 equals a negative 2. I solve, I subtract 5 on this one. I get a equals negative 3. Here, I subtract 5. I get a equals negative 7. So now, remember, you have to check these answers. So I'm plugging that in. Negative 3 plus 5 is 2. Absolute value of 2, 2. 2 times negative 4, negative 8. Plug in 7. Negative 7 plus 5, negative 2. Absolute value of negative 2 is 2. 2 times negative 4 is negative 8. So yes, they both work. Now, I'm not going to work this whole one, this next one, but remember, I want the absolute value by itself first. So the first thing I would do would be add 1. I get 2, absolute value of 3x minus 1 equals negative 4. I divide by 2. I get the absolute value of 3x minus 1 equals negative 2. Now, this is an exception. The exception here is I can never have an absolute value equal to a negative number. Okay, so I can never have an absolute value equal to a negative number. Will I ever get a negative number working an absolute value? No, you will not. So this one is no solution. All right, so let's get on to what today's homework is. So we're doing 1.5 and 1/6, solving inequalities and compound inequalities. Now, you guys have done these before, and so what I want to do is just do a little bit of review. So the first review is this. If I have less than or greater than, that is a dotted line. No, I take that back. Not a dotted line on this. It is a dotted line if you're graphing it. It would be an open dot. When it has equal to or the line underneath it, that is a closed dot when graphing. Okay, so let's work this first one. I need to get all the variables on one side and the numbers on another. Okay, so in order to get all the variables on one side, I would first subtract 4w, and I'll get w plus 6 less than or equal to negative 2.5. I'm going to subtract 6. I get w is less than or equal to a negative 8.5. So to graph that, this means it would be a closed dot. So I'm going to put a closed dot. I'm going to label that dot as negative 8.5. And then I'm shading. So remember, if my inequality is, let's see, if my variable is on the left-hand side, whichever way my inequality is pointing is the right way to shade. So if I have this or this, and my variable is here, I'm always shading that direction. So the same way they're pointing. If I had x and greater than, x greater than or equal to, then that means I'm shading this way because of the way my inequalities are pointing. So let's do the next one. To get rid of that 5 on the bottom, I'm going to take 3.6 times 5 equals 18. So I'm multiplying both sides times 5. So those will cancel. I get negative z less than 18. Okay, so when I do z, I always draw the line through it. Then I'm going to have to divide by a negative 1. So I need you to remember, when you divide by a negative, you have to switch this inequality. Now when I switch that inequality, when I'm dividing by negative, I always circle that so that I remember to switch it. If not, sometimes I forget. So I say z is greater than negative 18. So I'm going to put an open dot. Oops, that really didn't look like an open dot there. I'm going to put an open dot, negative 18, and it's greater, so it's going this way. So remember, whatever way the inequality is pointing, as long as your variable is on the left side. All right, so let's work this one. I am going to work this one with you, then I'm going to give you a chance to work the next one. Okay, the easiest way to get rid of that 6 is to multiply both sides by 6. So that means I'm distributing that, 14 times 6 is 84. 84 minus 12s greater than or equal to, these 6's cancel, so I get 3s plus 9. Be careful when you're using s. I don't really like using s because it looks like a 5 a lot of times. So if your handwriting is not that great, then maybe making that an x. I don't care, it doesn't matter to me. So I need all my variables on the left side, so I'm subtracting 3s. When I do that, I get negative 15s. Then I am going to subtract 84 from both sides. And I get a negative 75. Now what do? I divide by a negative 15. I'm dividing by a negative, so I'm circling that so I don't forget. This cancels. I get s is less than or equal to 5. So I go to 5. I'm making a closed dot because it's equal to, and this is 5, and it's less than, so it's going this direction. Okay, so what I'm going to have you do is the next one, and then I'll come back and we'll see if we got the same answers. All right, so you guys should have gotten negative 5/3 open dot. If you didn't, then holler at me because maybe I screwed something up. Okay, so interval notation. I want to talk to you about interval notation. So when I have less than or greater than, those are parentheses. So remember, it was an open dot. So anytime I have an open dot, it's going to be parentheses. Less than or equal to, greater than or equal to, brackets, and closed dot. So those go together. So if I look at this and I have an open dot and it's going this way, where's it going? Yeah, right. So it's going to negative infinity. So negative infinity and infinity, whoops, that looks like an 8. Negative infinity and positive infinity. Those are always parentheses because that's not a stopping point. A stopping point would be a bracket or an inclusion. So when I'm writing this, I would say, in interval notation, I'd say negative infinity to 2, because that's an open dot, parenthesis. This one, it's a closed dot, and it's going to positive infinity. So then I would do bracket, where the negative 2 is, to infinity. I didn't show you one with 2 brackets, so let's look at what that would look like. If I have closed dot here at negative 3 and an open dot at 4, and it's everything in between. So then what you would do is bracket negative 3 to 4. Whoops, 4 parenthesis. All right. So let's go ahead and look here at when it's compound. So first, if it's compound, so if I have y is less than or equal to 7, negative 7, or y is greater than negative 1, that means I would have 2. So compound means I have to have this union sign in between because I want to include them. Okay? So if I'm writing this one, what I do, I put it on a number line. I put negative 3 and I draw it. So now I know this is negative infinity to negative 3 bracket. On this next one, it's 2 little ones, so I'm putting them both on a number line. I have 2, it's an open dot, and it's going this way. I have 14 at a closed dot, and it's going this way because of the inequality sign. It's telling you that. So now I have, this is at negative infinity, this is at infinity. So now I have negative infinity to 2, parenthesis, union, close dot, so bracket, 14 to infinity. Okay, you guys do, sorry, I cut myself off. You guys do number 3 and 4, and then let's check our answer. Okay, so check 3 and 4, make sure you got what I got. Then let's go to 5. 5, if I give you something written in interval notation, I want you to put it on a graph. So it's a parenthesis, so that means it's an open dot at -1. It's saying it's going to infinity. Infinity is on this side, so that means my graph is going like this to the right. All right, very good. Okay, let's look at compound inequalities real quick like. So for compound inequalities, remember, if I have less than or equal to, that is always an and problem. If I have an and problem, that means I have a graph that looks like this, and it's shaded in the middle. Super easy to solve this. I have 10 less than or equal to 3y minus 2 less than 19. I'm going to add 2 to both sides. I get 12 less than or equal to 3y less than 21. Now I'm going to divide all the sides by 3. Now if you were dividing by a -3, you would have to flip all signs. So I get 4 less than or equal to y less than 7. So on my graph, I have a 4, I have an open dot at 7, and the y is in between, so that means I am shading in between. Okay, I want you to do the next one, and we'll come back. All right, so yours should look like this. 3 closed dot, 6 open dot, and everything in the middle. Okay, so we just have a few problems left here, 2 problems. Now it's compound inequality with or. Or is always greater than or equal to or. Okay, so you are literally solving 2 equations. So x plus 3 less than 2. So I subtract 3. I get x is less than -1. I have negative x less than or equal to -4. I'm dividing by -1, which means I flip the sign, -1. I get x is greater than or equal to 4. So I'm going to graph that. I'm going to open dot at -1, close dot at 4. And x is less than, so it goes like this, and 4 is greater than. Okay, you guys do the next one. All right, so you guys should have, oh, and then we should write this in interval notation just to practice. So parentheses, negative infinity to -4, parentheses, union, bracket, 3 to infinity. Actually, you need to make sure and do this on all your homework. I should have told you that. So let's go back up here and do one of these. So on this one, it'd be a bracket, 3, 6, parenthesis. You need to make sure and do that on all your homework. So number line and interval notation. Number line and interval notation on all problems. Okay? Have a good day.